hear me? Oh, we need this for that.
We have this.
Viewers.
Yeah. Although it's good acoustics in here, so.
Yeah, but there's webcasts. Okay, so I'm going to have to constrain my normal tendency to wander around aimlessly. All right, well, thank you for the introduction, Yang and Steve. I'm going to give you an update of what we've been up to in the hub over the last 12 months since the last meeting. And it's been a really busy 12 months. We've made, I would argue, a tremendous amount of progress over the last 12 months. Of those issues of recommendations that Yang put up, we've actually addressed, I think, almost all of them. And before I proceed, I'd like to, since Steve brought this up and Yang brought up the good map, I think it's maybe an important thing to realize that one thing that's happened over the last 12 months, especially with the evolution of the BD2K program, with the increased focus on building anatomical molecular level atlases that we're seeing kind of across ICs, kind of just the general trend of, with the NIH Data Commons pilot. I'd like to make this observation that Facebace is not existing in isolation, that we've been quite lucky that the people who are involved in Facebace have played core roles in, I'm the PI on the GoodMap Hub, for example. If you look at the current GoodMap site, you'll notice that there's a number of things in common with Facebace because we're building on the same technology base. We're involved, as Steve mentioned, in the BD2K data pilot. So Facebace is actually is part of this overall community of data sharing in the production of what's called in the community fair data, the data that's findable, accessible, interoperable, and reusable, that we're part of this overall community. And Facebace is actually, I would argue, an exemplar of how this should work, that the data that's in Facebace is both incredibly rich and heterogeneous. We have large numbers of good data sets. What we'll talk about when I show you the slides is we're actually doing things that are not just kind of keeping up with what other people are doing, but I think Facebace is really exemplar of how we should be building these repositories and how we should be interacting with the community. And I think we should be, as this collective group, quite pleased with how this is working out and that we're actually leaders in this area. So with that, I'm going to kind of drill in and give you an idea of what's been going on. So I'll give you the summary slide, and then you can fall asleep at that point. So we've done a number of things. Each of these represents a large amount of work. We've seen overall growth in the number of data collections, and we're seeing nice growth in the usage of Facebace, and I'll show you some numbers with that. Obviously, we can always do better, but I think the trends are in the right direction. We've made major enhancements to the Facebace database and service. Much of this is perhaps invisible to you, but it's really set up the ability to do lots of really interesting things, which I'll talk about. We've, last year at the meeting at Harvard, we talked about introducing the notion of self-curation. That has now been brought to bear. All of you who are contributing data have interacted, I think, with the self-curation tools at some level. And I would say that's turned out, my take is that that's turned out really well, and I'll give you some statistics of that. We've been working really hard with Axel's group on building out common bioinformatics pipelines so we could get the ability to aggregate across our RNA-seq and other omics data. And Mike Cherry has been really helpful in that. We've actually implemented the ENCODE pipeline. And so that's worked out quite well. We've made a number of enhancements to the user presentation and the browsing. And I think the statistics bear out that that has been effective. We've made some major improvements in the presentation of the sequence data. The JBrowse plugin is now live. We've done quite a bit of work on that, which we presented earlier, and also continued working with TrackHub. And we've been doing work in getting user feedback in terms of doing some detailed user surveys and feedback and driven some improvements based on that information. So now I'm going to drill down a little bit and give you some more detail about all these things. So first of all, with data usage and statistics. So what we see is now currently within Facebace, we have at 777 data sets. Rob would like me to caution that these numbers are all a little funny. What's a data set? What's an experiment? There's also been a shift in the way the data has been packaged from previous data submissions to current ones. But the takeaway here is we actually have a reasonably large number of experiments represented in FaceBase, a reasonably large number of submissions, and a good number of data files, over 6 terabytes of data now. That continues to grow. The real important thing about this picture is the fact that we have 7 different data types. FaceBase is really unique in all the repositories that I know of or I'm involved in the diversity of the data that is collected in the FaceBase repository. We made a huge effort in trying to provide an integrated view of these heterogeneous data sets. I think we've done a lot of progress in that area. It is a challenge, and it makes FaceBase unique and something that I think is now reasonably well under control. Steve mentioned this issue about data curation. Earlier in FaceBase, a challenge always was in keeping up with the rate of data submission, with the ability to get the data out available to the community. We addressed that in the initial phases of FaceBase 3 by implementing a curation pipeline that had this kind of incremental step where we would take the data in and it would not be very well characterized, and then we would have another step where the hub would go in and provide more detailed data, where the spokes would submit with a spreadsheet, and we would go back and forth, and that was a bit painful. We have since converted over to a pure self-curation model, and as you can see from these statistics, what that's resulted in is the backlog of data that's been submitted and not available to the community is essentially dropped to almost zero. There are right now a few data sets that have been submitted by spokes that have not gone into the initial state, which is the release state. So that's pending on additional work by the contributing spokes. So I think this is a real tremendous success story here that we've transitioned to self-curation, and it seems to be working. I want to make an important observation. Steve mentioned BioCaddy and the fact that there is a searchable archive in BioCaddy. We're, as part of the Commons project, kind of very involved with the BioCaddy group and the data modeling group. There's so-called DATS model, which is the data model that's part of BioCaddy. So I want to make this really important point that the modeling and metadata we have in FaceBase, which is self-curated, is actually way more detailed than is in DATS and it's in BioCaddy. So you can discover data within FaceBase much more granular than you can in these public models. So I think this is, again, a real success story, and we should be very happy with that. And this also sets us up for FaceBase 3 because of now the fact that the curation process scales to the data contributors. Looking over the data downloads, we've also seen, I would say, good progress with that. We've seen 1,000 data file downloads, 21,000 thumbnails. As we look towards pushing more data into the presentation in the browser, there's this fuzzy line, which is that, well, if you can see a picture, do you really need to download the data? So this is why we've included the thumbnails. We've also had a significant number of views of our data through the UCSC genome browser. So we think these are all trending in the right direction. Another thing that you could look at is actually number of interactions with the site. The number of page views, which is the real good metric, has gone up over the last year, so we're up to 61,000 page views. The rest of these metrics are a little bit fuzzy because of the way Google Analytics is, due to privacy issues, the way things are being tracked now is different and slightly less granular, so we might not want to take some of these other measurements too seriously. But again, I would argue that the trends here are in the right direction, so people are using the site. A significant number of the interactions with the site are through the new data browser, 30-something%. I think industry-wide, a 3-minute average, 3:30 average session duration is actually viewed as pretty good. So again, I think we're trending in the right direction here. Obviously, there's always a desire to do better, but I think the story here is looking good. So that's kind of an overview of where we are data-wise and usage-wise. So again, to summarize, the latency in data curation and availability to the community has essentially gone to zero. It's really now predicated on the spoke engagement for curation. The spokes are engaging in curation, which was a big question in our minds. So we seem to be getting good turnaround with good high-quality curation. It's very detailed work. And we see the interactions with the site going in the right direction. So I think that's all quite good. I want to talk a little bit about now what is going on in the underlying data service. This is a little bit more back-end stuff, but it's quite important, and we ended up spending a huge amount of time. Anyone who spends any time hanging around my group at USC knows that every other word out of our mouth is data model. We think this is really a critical aspect because if you want to promote reusability of data, it's all about the data model and findability. It's all about the data model. And one of the challenges, as I mentioned in Facebace, is that it's actually, in terms of the diversity of the data types, quite hard, quite broad. It's not like we're just looking at sequencing data, or it's not like we're just looking at imaging. It's the fact we've got all these different things and we're trying to tie them together. So this is just a listing of the different types of experiments we're running, and this is just a partial list, and also the types of data that we've got. And again, this is a partial list. So this makes a real challenge because what we really need to do is come up with this sweet spot where we're capturing enough detail about the data that we can find it and reuse it, but not make the description so detailed that it's burdensome to submit the data and collect the metadata associated with it. So you can have a really beautiful model, but if it's so hard to use, nobody uses it, then you've kind of defeated the whole purpose. So we've done that, and Rob especially has done a huge amount of work, and Alejandro, in trying to find that sweet spot in the data and coming up with, not too hard, not too soft. It's the kind of the Goldilocks paradigm here. And a lot of this was driven by the work with Axel, where we were wanting to drive these RNA-seq pipelines. And so that drove a lot of this, but we addressed it quite holistically. So what that's resulted in is a significantly improved representation of the data. This is just a high-level picture of this. We've driven this, again, looking at the overall goals, for example, of the NIH Commons program, where we want data to be findable, accessible, interoperable, and reusable. So we can achieve findability because we have a uniform representation of diverse data with enough detail on it so we can pick one piece of data out of the other. We have integrated and exploit controlled vocabularies, and that promotes interoperability. And then it's reusable because we have taken stuff from being hidden in the description field and hidden in a data lump and exposed it explicitly in this data model. So that makes it possible for us to understand what happened so we can reuse the data. And we'll see how that has played out in the standardized RNA-seq processing. This was essential to being able to do that, which is coming up next. So I'm really quite pleased with this. It's really an exemplar as to how this should be done. And if people are interested, we can give you arbitrary, boring details about how we actually achieve this. So all the data in Facebace is in this new model, and it promotes all this stuff. Bioinformatics pipeline, one of the things that came up a year ago was, we can't really compare our RNA-seq data. It's all done differently. So we kind of implemented almost by fiat the procedure, look, you can do whatever you want. We want the raw data. We want whatever processing pipeline data you've got, but we're going to do our own, and we work with Mike Cherry, and we decide we're just going to use the ENCODE RNA-seq model. So, so what we have put in place and is almost ready to execute in mass now is a standardized RNA-seq pipeline. So it will allow us to aggregate and compare data across spokes. And so there's been a lot of work done. It's been really quite informative. And again, this is really, I would argue, an exemplar of the way things should be done. So data comes in from the spokes. It's curated, self-curated by the spokes into the data model. We can then go into the repository, find the right data, pull that out. with appropriate fidelity so we know how to do the processing based on the details of the experiment. We package all that up using standardized tools. We push that into DNA Nexus, which is the current platform that ENCODE uses for running their pipelines. We run the standard ENCODE pipelines. We get the data back out of DNA Nexus, and we re-ingest that into the correct place in the database. So now we have the standardized pipeline results as well. We have raw data, whatever pipelines were run by the experimenters, and then the standardized pipeline. So this is something we call in the field of knowledge turn. So the fact that we can take data in, extract it, reuse it to do the pipeline processing, re-ingest it, and make that discoverable is actually, I think, a big deal. And the fact that we're doing this, I'm incredibly pleased that we've achieved this. So we basically closed the loop. We've done all the testing. We'll be ready to run this in mass. And now this is totally scalable. As long as people put the data in using our tools, which we know they can do, we can run the standard processing on it and create value out of this aggregate of the data collection. We've done a lot of work in the browser, which hopefully you've seen and hopefully you like. So we've redesigned the search and filtering interface with the idea of allowing you to do much more in-depth and rigorous searches. We've added better search and navigation. We've integrated 3D surface models. Those are now available. We've done a lot of work in enhancing the JBrowse gene browser enhancements, which we think are JBrowse is a nice tool because of the extensibility and the fact we could do tight integration with the data. So Kyle Chard and his group at University of Chicago has been driving that. We've done a lot of work on trying to improve the page layout to make it easier to understand and spent time making the overall performance of the system better. So this is a picture, and we'll do a demo. I'm going to stop talking soon, and Rob will run a demo so you can see all of this stuff live. We've done a much improved search interface. So this includes here the ability to, now this is actually an important thing. So this is this kind of shopping cart kind of selection, so-called faceting interface. These values are all driven off of the controlled vocabulary. So this allows you to interact through controlled vocabulary, allows you to construct interactively fairly rigorous search criteria. This includes things like histograms. So if we have things that are kind of distributions of values, you can select interactively and graphically using histograms. So there's a lot going on here, and Rob will show you that. It also allows you to transparently navigate through nested model. So if you have things like replicants, and underneath that you've got the, for example, gene values, it allows you to kind of search through this complex model and flatten it out. So it allows us to have this rich model for reuse and reproducibility, but present it in a simplified way so end users aren't overwhelmed with the complexity of the model. We've done one thing that's been clear for a long time and shows up in other things like GoodMap is that since we're dealing with anatomy, doing anatomical navigation is a really convenient and intuitive way for users to interact. We had shown a prototype of an anatomical browser last year. This has now been rolled out in the latest release of the site, which I think was like last week. So this includes the ability to then interactively go through these surfaces, and these are all linked. So when we select it, and they're linked through the shared vocabularies, so you can go from one of the elements in the surface model to the data associated with that anatomical region. We've also done a significant amount of work on making the JBrowse experience equivalent to what's in the Santa Cruz browser. And again, we think this is the right way to go because of the it's a much more kind of modern platform, and we can link this much more intimately with the rest of the data. And so this gives us a good place to go to do more sophisticated interactive browsing in the future. Data submission, I've already talked a bit about that. We have done a lot of work on the self-curation tools, really focused on usability here. So we kind of rolled them out last summer. We've provided desktop tools for uploading. We've provided browser-based tools for editing. We've spent a lot of time creating training materials and do one-on-one training, so Chris has driven a lot of that. And so far, we have 66 data sets that have been self-curated. And again, I think this is actually a big deal. There are certain people who would claim that self-curation does not result in high-quality data. I think what we're showing is the contrary, that we have gotten high-quality data that's reusable, that is curated by the creators of the data. So I think this is a big deal. So there's a variety of ways we can do this. So we've got online curation forms and file upload. And so this is just a picture of what that looks like. We've got desktop and command line upload tools. And so these are a picture of what this looks like. And I'd like to make the point, again, another important point, these tools are all driven off of the data model. There's no custom coding that's gone into any of these. So if we decide we need to add a new feature, we basically don't have to rewrite any code. All the upload scripts, all the user interfaces, everything just automatically tracks what's going on, and we bring in this, the new metadata. So with that, we're going to proceed to the demo. And Rob is going to take over. And by the way, at this point, if there are any questions, I'm sure if people want to know things, Rob can steer the demo in that direction. So with that, I'll turn it over to Rob.
I'm going to trust that everyone can see our screencast now. Okay, so back to our demonstration of the site. I'm going to do a walkthrough, but highlighting the new features, just mentioning some of the things that Carl touched on in his talk that have been really represented a lot of our effort over year 4 and some of the big accomplishments that we've had in this past year, improving the site, improving the data representation. So beginning at the top here of the site, a few links have changed a little bit. I'll just point that out because I know that sometimes when you come back to the site, subtle changes you might notice. Now, because we've aligned some of our investigation terms, the experiment type terms, with the Ontology of Biomedical Investigations, OBI vocabulary, some of these have changed a little bit, and any of you who are data submitters, I would encourage you to go to the site, take a look at your data sets, and just make sure that you're familiar with the changes. If anything seems a little bit off in that translation, please let us know. Now, when I scroll down here to the mouse data summary, one of the neat changes here is that over the past year, we updated this so that it is now more integrated with the rest of the new search and filtering interface. So initially, we had preserved the functionality that was inherited from Facebace 1, and there was a popular mouse data summary like this on the site. And as you clicked on the different links, like essentially looking at an inventory of data or on some of the axes here, you would get a listing of that data in a pop-up. Now, as we click on it, we'll drill down into the search interface and go to the new search and filtering interface. So as I click on this, it takes me into the new filtering interface, and it sets those filters per what I had just selected from the mouse data summary. And the other exciting thing for us is that we have done some enhancements to that so that we're now able to reuse it with other dimensions of our data. And so we're going to be exploring that just to give you an idea of what's coming up in year 5. So because I'm now in the filtering interface, I can continue my search from here. I can expand my search out of the particular filters that I had initially set. So I'm going to kind of reset here to a broader view. And then, as you see on the left-hand side of this new interface, it's kind of being dynamically updated as I go. And that was one of the things that we had heard in the feedback from our users and from those of you who test the site and provide us with that input, is that you'd like to see the filters open on the left-hand side so that you can see it changing as you go. So if I look over here again at organism, pick mus musculus here, I see that not only has the search results updated, but any of the available filters have also adapted to the data that's available per that initial selection. So I'm going to continue my search here with RNA-seq assay, and I continue to filter. As you can see, that the performance is a bit improved if you were familiar with using it before. So I think when we started off, the the original search interface was performing well, but as the complexity of the site grew and additional features, we started to see a bit of a slowdown, and this re-engineering is not only a change of what you're seeing visually on the site and the user experience, as we say, but also a re-engineering under the covers and improving that performance. So another feature that we have here is that we can incorporate the keyword search into the faceting search on the left-hand side. So as I type in some keywords that might be found in the description, in the study design, in the title, that is fully integrated with the filtering pickers on the left-hand side as well. I'm going to go ahead and clear that out and then actually drill down here now to a data set and show you some of the changes that have taken place on the detail page. All right, so now we're transitioning from the search experience into looking at the details of a particular page. And here we're looking at a data set in FaceBase that has both RNA-seq and ChIP-seq data. We have an embedded browser here for the genome tracks, the track files. And while this loads, so it's pulling up the individual reads, or sorry, the reads, but it is doing some targeted reads of the underlying track file. So we're not going to the actual raw sequence data reads, but just, I mean in a technical sense, reading from the track files themselves. So we have that embedded here. As Carl mentioned, we worked with a number of your groups to talk about what were some of the default settings for this that you'd like to see so that we can improve it for when a new track file comes up without any additional configuration. This is about how the default of that looks now, and feedback so far has been very positive. We can also pop it open in another window. And again, just to give you a hint of what's coming in year 5, we are going to work on hierarchical display of the tracks so you can enable large chunks of tracks at one time, look at tracks from across different data sets, and be able to just individually pick and choose what you want to see. You can already do that right now, but it is shown within a particular data set. All right, so back to the detail page. So one of the enhancements, although relatively subtle, I do want to point out that now some of the listings of terms that we had, initially they would be shown with taking up a little more real estate. We've streamlined that so things kind of blend together on the page. Hopefully when you look at this, you don't notice the difference, but if you were familiar with the previous site, there was additional real estate taken up for some of the tags and annotations. Now, as we scroll down, we get to the experiment section, and this is part of the big remodeling of the database model that took place over the previous year, where now we've broken down information and kind of combined things from different assay types so that you could search and locate data from across, whether it's genomic or imaging data, you can find it in a combined way at a level of description that's called the experiment here. So I'll drill down into the experiment because this is where we start to get into the data files that we can download. So now what you see is that we have a description of this particular RNA-seq assay at a high level so that it's just enough information to be found in the system with enough detail about how the data are connected so that it could be reused. So we have an information on, in this case, one biological replicate was used in this assay. We have sequencing data, we have a couple of reads, we have process data, we have the aligned read, we have the track files as well, the bigwig tracks that showed up on that page. So we can drill down and find out exactly what data we have in the system. This is part of that trade-off between having data that's simple enough to use both as a data submitter and as a data consumer to be able to find it, but enough detail that we can drive automated pipelines through it as well. So this gives us the structure that we can do that. So we can take this, and this is part of the validation work that's going on right now with Matthew out of Axel's lab, that we're taking this data and automatically processing it and then being able to return the track files back into the system is a part of the validation step that's going on right now. Let me just, if I step back to the overall data set, and again, just looking at the detail here, If I scroll down to a ChIP-seq assay, again, we just have more detail in this. We know more about the data without human interpretation. So in a less detailed model, you could maybe still determine the same things, but you, as an individual researcher, would have to look at it, read the text, read the description, maybe interpret some of the encoding of a file name, for instance. And in this case, it's just built into and codified in the model itself. So we see in this case, we have a ChIP-seq assay. We have 3 related ChIP-seq assays. And the reason is that we see under here the target of assay, that this particular assay was used as a control for the others that were targeted to a particular histone marker, I believe it was. So that's kind of an idea of the detail that we have now. Also, with this new interface, we can do similar faceting deeper into the model. This is something that although we had more detail in our model, and you could see it, you're now able to drill down and do more searching across it. And again, due to this new filtering interface, when you look at experiments, what we're seeing on the left-hand side in the filters are actually attributes that come from deeper in this data model. So we enter the data once, we're able to search it in many different ways. And just another enhancement to the site that improves usability without driving up a lot of the cost of the curation or of the consistency, maintaining the consistency of the data. Okay, so we've seen the filtering interface, we've seen the genome browser interface. I'm going to open up another tab and hopefully get a tab that you all see. And I'm just going to type this one in. All right, so now moving to what we're doing for year 5. This is just a proof of concept. The underlying tooling is good and available on all the sites, but I would just kind of add a significant disclaimer that the layout of this page, this is just a proof of concept. But what we see here is driven out of real data, real viewer. So this is part of our year 5 work in terms of providing the anatomical navigation. This was a model that was generated out of Yang Chai's group and uploaded using our tools by their group. So the hub just provided the tools, they did the curation of it. It's actually one of the data sets that's in Facebace. You can see this kind of rendering on every single page. Embedded on the page here, we're exploring how we're going to integrate it into the site to provide navigation through the visual model itself. So I can take a look at I can see all of the listing of terms that are linked to the different structures in the model, things that I can kind of look at, turn on and off, adjust their opacity. And then as I clicked on the links here, what I get is loading those term pages and the related data sets in the viewer. So as we move forward, we're going to want to leverage this tooling to be able to provide these interfaces so that it's more incorporated into that filtering interface so that we have visual navigation. You can drill down and see these models, drill down and select different, in the genome browser, select different tracks and be able to view data and cross-compare from different data sets. Okay, and with that, that concludes our demonstration of the new features. And at this time, I can take questions, or Carl can field your questions as well. And if not, we can move on to the next speaker.
We have one more slide.
Oh, you do? Yeah, that's right. We have a whole summary of year 5.
Yeah, one more slide here.
I'll kick you out of here.
And then we'll move forward. So, let's see, is that it? Oh no, this is it. Yeah, so we're ongoing. Year 5, we've got a lot of plans. So we're completing, as we said, the bioinformatics pipeline, and that should be rolled out in Anger, and I think probably in the next small number of weeks. We're just finishing the final validation, and again, this is really, I think, quite, my impression is this is actually pretty unique work in that we are going everything from the data submission through the curation process and then the reintegration. We're continuing to work on vocabulary enhancements. We've done a lot of work on how we represent those and tying those together. We still probably have a little data cleanup to do on some of the older data and integrating richer vocabularies, for example, the Mondo vocabulary, which is the mammalian disorders. So that is, and then we're also going to improve the search across, now that we have all the structure in place, we can improve the search mechanism, so we're searching across classifications, for example, enclosure or containment, anatomical enclosure or containment, or synonyms. So we'll see improved search that will leverage the use of vocabulary. The anatomical navigation will be rolled out. We're continuing to do work on displays of some of the visual data. The one thing we've done now that we've disaggregated the data is there is a need to re-aggregate the data. And so we have basically all the and by that I mean we would like to be able to assemble data collections and then download them as a unit. And we have tooling in place to do that, so we'll introduce that in FaceBase. Another nice thing that will come out of that, which, well, I'm going to get to that in a moment, but I'll skip ahead. Another nice thing that will come out of that is once we create these aggregated collections, this is something any user can do, and those will become citable. So USC is a member of Dataset, so we are capable of minting DOIs for our data collections. Every piece of data in FaceBase is citable through a proper data reference. So we've done a lot of work on data identifiers integrated into the site. So everything is properly citable, which before it hadn't been, and all our citations are what's called resolvable, so we can go right to the data. So we now have a mechanism for creating collections, downloading them as bulk data, creating citations for them, so when you write your papers, you can cite the data that went into your individual figures, and that will all come out in year 5. All those pieces are in place. We need to roll them out. Continued work on dashboards and notification, data quality, control metrics. One thing I'm interested in doing, or we're interested in doing, is the ability to look at the progress of the self-curation and identify outliers to make sure that the data quality is maintained. Let's see, increased work on JBrowse. So Rob mentioned that, for example, to be able to do cross data element browsing of the genomic data. I'd mentioned the FAIR identifiers and resolver. As we've said, we're deeply involved in the data commons and the production of FAIR data. We've got actually in this release a lot of stuff hidden under the covers that really promotes FAIR data creation and reuse. And one of those things is everything is citable using proper identifiers. And there are other things as well. We also have historical tracking that's in the site. We haven't exposed it yet, but we track all the edits and changes, and everything is versioned implicitly. So again, when we have a citation, it's to the actual data. So even if somebody went and changed it, we know that, and we can cite the old version. Sometimes that's necessary. And then just continued ongoing focus on improvability and usability. We're working on deeper analytics into the site, better kind of tracking what's going on in feedback. So continued improvement on usability, and of course, ingest of all new data that's coming up over the next 12 months, 10, or 11 months and 28 days, or whatever it is. So that's the summary. Just people in the hub, raise your hands so everyone so we can congratulate people for all the excellent contributions and work that took place over the last 12 months. We'll be here. If you have any questions, you can talk to us. Of course, you can send us mail. We're always interested in feedback. Sorry? Except for me. Steve, we don't like to hear from, but everyone else, we'll take your calls. I've got them on the do not call list, right? So, all right. Well, with that, we'll move on to the next. Yeah, you can ask a question.
Website. Is there a are there any plans, and I think we had discussed this at one time, about having tutorials on craniofacial development or anything of this type for people who are totally new in the field and coming in? And I'm just looking, and this I didn't know that they had on GUDMAP because I haven't looked at GUDMAP in a long time, but they have things on protocols, they have things on, so we have the 3D atlas to some extent, but are there plans to do things which are beyond sequence analysis and data sets and so on Facebace that would be a good introduction for people who are not in the field and who want to get into the field?
So you mean in terms of the tutorial material?
Yeah.
Yes, so
I think we had discussed that previously.
if that's, so I guess there's two answers. I mean, so as I had mentioned, yeah, I mean, as Pogo said, we've met the enemy, he is us. We are GoodMap as well. Chris has been responsible for curation of a lot of that material. We did have that content generated. So if there's interest in that kind of tutorial material, and I think we have some of it, is on Facebace, but I would say if we had an initiative to generate the content, we would certainly figure out how to disseminate that. And things like protocols as well. I mean, in GoodMap, that was a real important thing. People really wanted the protocols. To be honest, that's been less of an, I don't think I've heard that brought up here.
But yeah, protocols I think protocols I hadn't brought up, or I don't think it has been brought up here either. I think tutorials had been brought up, and I'm just wondering whether there's an argument against bringing this in, because in a way this could be useful, again, for people who have, let's say, a phenotype, they want to start looking at it, they want to start analyzing it, it would expand the community. Is there an argument for not putting it in?
And the only argument I would think is you have to generate content and make sure it's correct.
Yeah.
And so there's some effort that's involved in that.
Right. Yeah.
Right.
I think that's a very important point. We have generated videos like for that and then use that to thank you, Tim. So we have generated videos in which you can use to train postdoc and graduate students to learn normal craniofacial anatomy, and that also will be serving as a base for future data navigation. These are the things that definitely we will develop more. I think we can put it on the site.
Yeah, so let me give you an example. In GoodMap, there's a strong interest in kind of anatomical development, and the anatomy in that part of those nether regions is quite complex. And so we've actually have anatomists who have gotten subawards who are taking path images, and they're actually going through and they're hand annotating all these with anatomy, and then we'll tie it in through the same kind of structure you saw from the surface volumes into the site. So now this becomes a training tool, and it links to the data and so on. And so that technology could be applied here, but then what we need is somebody to take the images and go through and do all the annotation.
Oh, yes, coming. Hold on.
Downloaded, how many downloads there are of our data? Yes, I'm just curious if we have information of downloads of data sets being used by external individuals, groups.
Yes, so this is the download information. Again, this is people actually, so, and actually Pedro brought up this point. It's an imperfect view. So for example, people are accessing face-based data through geo. We don't track that. So there's some things we just don't have the ability to see. This is the number of downloads directly from the face-based site. So those are places where people went in and said, I want this data file, and actually downloaded it. But again, downloads, so then the question is downloads the right metric? It's one potential metric. So these kind of more web analytic things. So that's why this, thumbnail downloads. So this is people who are actually looking at images on the site where they might not have downloaded, actual data files. So this is the one thing we do track. And there's been this ongoing question as to whether file downloads is the right metric. But again, it's not a million, but it's not zero either. So there's a question as to, again, is this the right metric? And if so, then what should we be doing to drive that metric higher?
Any other questions?
Any other questions?
Okay. Cool.